Hi friends, in this video we are going to discuss operation of induction motor. Let's see here. Generally in induction machine we have two parts. One is the stator and another one is the rotor. One is the stator and another one is the rotor. When three-phase AC supply given to the stator, when three-phase AC supply given to the stator, then it produces rotating magnetic field. Listen carefully. It produces rotating magnetic field, which is called as stator rotating magnetic field. Stator rotating magnetic field. When three-phase AC supply given to the stator, it produces rotating magnetic field which rotates in clockwise direction with the synchronous speed. Listen carefully here. The operation is very important. Okay, when three-phase AC supply given to the stator, it produces rotating magnetic field which rotates in clockwise direction with synchronous speed. Then after, due to mutual induction, the flux will produces in the rotor also. The flux will produces in the rotor also. That flux is called as rotor rotating magnetic field. Stator rotating magnetic field and rotor rotating magnetic field, which rotates in clockwise direction with synchronous speed again. Which rotates in clockwise direction with synchronous speed. When three-phase supply given here magnetic field produces which rotates in clockwise direction with synchronous speed. Then due to mutual induction, the flux will produces in the rotor which rotates in clockwise direction with synchronous speed. Right, sir. Then, now here the very important point is that due to mutual induction, nothing but generally to produce the EMF, we require set of conductors. Nothing but in rotor we have a set of conductors. Second one, magnetic flux. The stator flux is there to link up. We have a magnetic flux. And next one, relative motion between conductors and flux. Nothing but the rotor conductors and stator flux. Rotor conductors and stator flux. The relative motion also very important for induced EMF. Generally at starting, rotor speed is 0 and the speed of the magnetic field is ns. And the rotor speed is 0. So we have a relative motion here. That's why the EMF induces in the rotor. The rotor is short circuited. That's why the current will flows in the rotor. Then when current flows in the rotor, when current flowing through a winding, it produces flux which is called as rotor magnetic field. Due to mutual induction, actually, to produce the EMF, we required the relative motion between conductor and flux. At starting, conductor at 0 and the magnetic field at ns speed. Hence, we have a relative motion. That's why EMF produces in the rotor. Then after, current will flows in the rotor conductor. That current produces the flux is called as rotating magnetic field in the rotor. Have. Then, now simply according to Lenz's law, we have to more concentrate on Lenz's law now. Now, whatever due to this flux as well as this flux, due to this flux and this flux, interaction of two fluxes. Due to interaction of two fluxes, the torque will produce in the rotor. That torque tends to rotate the rotor. Now, my rotor is rotating. Now my rotor is rotating, some speed is taken as NR. What happened? When three-phase AC supply given, the stator magnetic field produces in clockwise direction with synchronous speed. Then due to mutual induction, the flux produces in the rotor, which is rotating magnetic field, which rotates in clockwise direction with synchronous speed again. Due to interaction of these two fluxes, torque produces in the rotor. That torque tends to rotate the rotor. Now, according to Lenz's law, tell me, the rotor should rotate in same direction or opposite direction? According to Lenz's law, what is the statement? Every effect opposes its very cause. We can say like that. Every effect opposes its very cause. What is the effect here? The speed is the effect here. Every effect should oppose the cause. What is the cause here? The cause is relative motion. What is the cause here? Relative motion is the cause, effect is the speed. Every effect should oppose the cause. Nothing but now our rotor speed should oppose the relative motion. Our rotor speed should oppose the relative motion. To oppose the relative motion, the rotor should rotate in same direction or opposite direction. For example, if the rotor rotates in opposite direction to this flux, if rotor rotates in opposite direction to that one, what is the relative motion? If both are in opposite direction, the relative motion is additive, N1 plus N2. If both are same direction, the relative motion N1 minus N2. If both are opposite direction, the relative motion N1 minus of minus N2. If both are opposite direction, N1 minus of minus N2, nothing but N1 plus N2. If both are same direction, N1 minus N2. Now tell me, to oppose the relative motion, the rotor should rotate in same direction or opposite direction. If it rotates in opposite direction, the relative motion increases, not nullifies. If rotor rotates in same direction as a magnetic flux of the stator, if rotor rotates in same direction as a magnetic flux of the stator, then the relative motion decreases because N1 minus N2, right? If both are opposite direction, N1 plus N2. If both are same direction, N1 minus N2. So, according to Lenz's law, the rotor should rotate in same direction. The rotor should rotate in same direction and equals to this synchronous speed actually. When both the speeds are same, nothing but ns and ns, then what is the relative motion? Ns minus ns, 0. Then Lenz's law is successfully completed. When the rotor rotates in the same direction with same speed, then relative motion ns minus ns, that is equals to 0. Then Lenz's law applied 100%. But actually, according to Lenz's law, the rotor rotates in the same direction with nearly that speed, but not equals to that speed. Actually, it should catch the synchronous speed. According to Lenz's law, it should oppose the relative motion. Oppose the thing, but it should be 0. Relative motion should be 0. For that cause, the rotor rotates in the same direction with nearly synchronous speed, but it doesn't capture the synchronous speed. Sir, why it is not catching the synchronous speed? Why it is not catching? Actually, synchronous speed is the speed of the magnetic field. The rotor speed is the speed of this mechanical rotor. Mechanically speed. This is electrically speed. This is mechanically speed. Is there any wind friction for this electrical speed? Is there any braking or bearing friction, brush friction for this electrical speed? There is no wind friction for this speed. There is no bearing friction for this speed. But for this mechanical speed, we have a wind friction and we have a bearing friction. That's why, due to that friction, the rotor doesn't capture the synchronous speed. And also even we have a load on the rotor. And also even we have a load on the rotor. That's why the rotor doesn't catches the synchronous speed. According to Lenz's law, actually it should catch the synchronous speed, but it is trying to catch the synchronous speed, but it does not catch us because of wind friction, bearing friction, and load. Wind friction and bearing friction and load, the rotor doesn't catches the synchronous speed. That's why always the rotor trying to catch the synchronous speed. Always the magnetic field always rotates at synchronous speed. Again, the rotor trying to catch the synchronous speed. Like that, the operation is going on. Like that, the operation is going on. Sir, for example, if my rotor captured the synchronous speed, then what happens, sir? If rotor captured the synchronous speed, what is the relative motion? Zero. If relative motion zero, there is no induced EMF, there is no current, there is no flux in the rotor. If there is no flux in the rotor, there is no torque. If there is no torque, the speed at zero. Are you getting or not? Generally, in synchronous machine, both are at same speed. But in induction machine, if rotor catches the synchronous speed, then torque is equals to zero. Rotor comes to rest. Rotor comes to rest position. Are you getting or not? This is the operation of three-phase induction motor. What I told you, when three-phase AC supply given to the stator, it produces rotating magnetic field which rotates in clockwise direction with synchronous speed. Then due to mutual induction, the flux produces in the rotor which rotates in clockwise direction with synchronous speed. Due to interaction of these two fluxes, torque produces. Actually, the torque tends to rotate the rotor, but according to Lenz's law, it should oppose the relative motion. According to Lenz's law, the rotor speed should oppose the relative motion between rotor and magnetic field of the stator flux. For that, the rotor rotates in the same direction. With nearly same speed, but the rotor doesn't catches the synchronous speed because of wind friction and bearing friction and load. For example, if rotor catches the synchronous speed, then relative motion zero. If relative motion zero, EMF zero, current zero, flux zero, torque zero, there is no motion. Right? This is simply, so always in induction motor, the rotor speed is less than synchronous speed. Always in induction motor, rotor speed is less than synchronous speed only. The rotor doesn't catches the synchronous speed. Always the rotor trying to catches the synchronous speed, but it is failed to catch the synchronous speed. Failing to catch the synchronous speed, again trying to catch the synchronous speed. That's why the rotor always rotating at the speed. Okay, this is about the operation of three-phase induction motor. Operation of three-phase induction motor. Let's see here. I told you we have two fluxes. One is the stator flux, another one is the rotor flux. One is the stator flux, another one is the rotor flux. One is the stator flux, another one is the rotor flux. For example, if this is my rotor flux axis, rotating magnetic field. For example, this is rotating at ns speed in this direction. Before that, stator flux also is there, which rotates at synchronous speed in this direction, for example. If it is in this direction, this is also should be in this direction. If this is in this direction, this is also should be in this direction. Whatever, both should be in the same direction. That's enough. Both should be in the same direction. For example, I am taking in clockwise direction, sir. No problem, sir. If you are taking in clockwise direction, for example, this is stator magnetic field and this is rotor magnetic field. For example, stator magnetic field rotates in this direction with ns speed and rotor magnetic field also rotates in the same direction with same speed. The angle between these two is called as delta. The angle between these two. So, what are the conditions to produce the torque in the machines. Actually, this is the diagram for induction generator. Induction generator. This is for induction generator. In induction generator, rotor axis advanced to the stator axis. Rotor axis advanced to the stator axis. Then it is called as induction generator. For example, if you are taking here, this is my rotor axis, and for example, this is my stator axis. Now this is the angle delta. Now see here, the stator axis advanced than the rotor axis. This is called as induction motor. This is called as induction motor, and this is called as induction generator. This is called as induction motor, and this is called as induction generator. In induction generator, rotor axis is in advance. In induction motor, stator axis is in advance. Stator axis is in advance. In induction generator, rotor axis is in advance. Now tell me, what are the conditions to produce the torque? What are the conditions to produce the torque? To produce the torque, we require two fluxes. What are those? Stator magnetic field and rotor magnetic field. We require two fluxes. Stator magnetic field and rotor magnetic field. And second one, relative motion between them. Relative motion between them should be zero. Relative motion between them should be zero. See, this is also rotates at clockwise direction with synchronous speed, and this is also rotates at clockwise direction with synchronous speed. Both are rotating at same direction, same speed. What is the relative motion between them? Zero. What is the relative motion between them? Zero. So, first condition, we require two fluxes. Second condition, relative motion between them should be zero. Relative motion between them should be zero. And next one, there is maybe phase displacement between two axes. The phase displacement may be delta, no problem. Phase displacement may be delta, no problem. So these are the conditions actually to produce the torque in AC machines. We require two fluxes, and the relative motion between them should be zero, and they may be displaced by some angle delta also, no problem. Right? Then the torque produces, then due to interaction of these two fluxes, torque will produces. The torque tends to rotate the rotor in the same direction with nearly synchronous speed but not equals to synchronous speed. This is simply the operation of three-phase induction motor. This is for induction generator and for induction motor. This is important. For induction generator, rotor axis is in advance. For induction motor, stator axis is in advance. Right, next one. In this operation, tell me, what is the speed of the stator? What is the speed of the stator? Sir, stator is stationary. What is the speed of the stator? Zero, no speed. What is the speed of the rotor? The rotor speed is NR. What is the speed of the rotating magnetic field of the rotor? NS. What is the speed of the rotating field of the stator? NS. In which direction? Clockwise direction only, all. Now, can you tell me what is synchronous speed? The speed of the magnetic field. Can you tell me what is the formula for synchronous speed? NS is equals to 120 F by P. Very good answer. Can you derive the formula? How it will? How you can get this one? Let's see, formula, derivation. Actually, we know the basic formula, theta electrical is equals to P by 2 times of theta mechanical. This is the basic formula. If it is written in omega, omega electrical is equals to P by 2 times of omega mechanical. Omega electrical, what is the formula? 2 pi F, omega in electrical. P by 2 into omega mechanical, 2 pi N by 60. 2 pi gets cancelled. Then n is equals to 120 f by p. This is called as synchronous speed. This is called as synchronous speed. Now synchronous speed ns is equals to 120 f by p. See here. For example, my frequency is equals to 50 hertz. For example, my frequency is equals to 60 hertz for 50 hertz and for 60 hertz. For example, P is equals to 2 for 2 number of poles. Can you tell me what is my synchronous speed? What is my synchronous speed for 2 poles? For 2 poles, nothing but 120 f by p. 120 f by p. My synchronous speed is 3000 rpm. 3000 rpm. For example, for 4-pole machine, what is synchronous speed? 1500 rpm. For example, for 6-pole machine, what is synchronous speed? 1000 rpm. For example, for 8-pole machine, what is synchronous speed? 750 rpm. For example, for 10-pole machine, what is synchronous speed? 600 rpm. For example, for 12-pole machine, what is synchronous speed? For 12-pole machine, what is synchronous speed? 500 rpm. These all for 50 Hz supply frequency. For 50 Hz supply frequency, for 2-pole, for 4-pole, for 6-pole, for 8-pole, for 10-pole, and for 12-pole. You have to calculate the same values here. For the same, for 2-pole, for 4-pole, for 6-pole, for 12-pole, what are the answers? Can you tell me what are the answers? First, calculate fast. Calculate fast and tell me what are the answers. Fast, calculate fast. Right? For 50 Hz supply. For 2 poles, 120 f by p. 120 f by p. 3600 rpm. Next 1800 rpm. Next 1200 rpm. Next 900 rpm. Next for 10 pole 720 rpm. For 12 pole 600 rpm. For 12 pole 600 rpm. These are the synchronous speeds for 50 Hz and for 60 Hz. You have to remember. Of course, we have a formula, sir, but if you remember these values, it is very easy to substitute it during the problem solution. Just 1 second is enough. If you want to try to substitute this formula, it will take nearly 15 seconds. Just waste of time. Yes or no? In competitive exam, even 1 second also very, very important. That's why you have to remember all these values. These are the different speeds, synchronous speeds. Right, it's completed. Now my question is, what is the relative motion between stator magnetic field and the rotor magnetic field? What is the relative motion between stator magnetic field and the rotor magnetic field? First question. Relative motion between stator magnetic field and rotor magnetic field. Can you tell me what is the relative motion between them? Both are same direction, rotates in same direction with same speed. So what is the relative motion? Ns minus Ns, that is equals to 0. This is our first question. The relative motion between stator magnetic field and rotor magnetic field is that Ns minus Ns is equals to 0. Now my second question, what is the relative motion between rotor and stator? Can you tell me now? The relative motion between rotor and stator. Rotor speed is Nr, stator speed is 0. Final answer is Nr. The relative motion between stator magnetic field and rotor magnetic field. The relative motion between rotor and stator. And next question. What is the relative motion between magnetic field and the rotor? Third question. Relative motion between the magnetic field, rotating magnetic field and the rotor. Rotating magnetic field and the rotor. What is rotating magnetic field? Both are ns only, both are clockwise only. That's why we can take any one of these. For example, my rotating magnetic field is ns and my rotor speed is nr. This is the relative motion between them. Relative motion between rotating magnetic field and rotor is ns minus nr. ns minus nr. Relative motion between two magnetic fields, relative motion between rotor and stator, relative motion between rotating magnetic field and the rotor, ns minus nr. Right? What is the relative motion between the magnetic field and the rotor? You know already this value, the magnetic field is ns and the rotor speed is nr, ns minus nr. ns minus nr. Now, this relative motion between magnetic field and the rotor is also called as a full load slip speed. Full load slip speed. Full load slip speed is equals to ns minus nr. It is called as full load slip speed. Actually, my synchronous speed is 1500, for example. My synchronous speed is 1500, for example. My rotor speed is 1450. My synchronous speed is 1500, rotor speed is 1450. I told you already, the rotor trying to catch the synchronous speed but does not catches the synchronous speed. Always less than synchronous speed, nearly equals to synchronous speed. Now tell me, what is the slip speed? The full load slip speed is equals to ns minus nr. 1500 minus 1450. 50 is the RPM slip speed. Slip speed, now why it is called a slip speed? When we are walking generally, if I slipped my leg, then my speed increases or reduces? Reduces. When we are walking, if my leg is slipped here, my speed reduces. Nothing but here rotor speed also reduces because rotor slipping. The rotor slipped. That's why the rotor speed is reduces. That's very simple. The slip nothing but the same. So this is my full load slip speed. My full load slip speed. Then after they are asking question another. What is the off load slip speed formula? Off load slip speed is equals to half load slip speed is equals to half into ns minus nr. Nothing but some xth load slip speed is equals to half load half into 1 by third load 1 by third into 9 by 10th load 9 by 10th into. For example, xth load, x nothing but 1 by 2 1 by 3 2 by 4, whatever it may be, some value. For xth load, the slip speed is equals to x into ns minus nr. Nothing but the xth load slip speed is equals to x into full load slip speed. X into full load slip speed. Xth load slip speed is equals to x into full load slip speed. Full load slip speed is equals to ns minus nr. Yes, we have a formula. Next question. I want full load slip. Full load slip is equals to full load slip speed divided by synchronous speed. full load slip speed divided by synchronous speed. What is full load slip speed? My full load slip speed is ns minus nr divided by what is my synchronous speed? Ns. So full load slip speed by synchronous speed, ns minus nr by ns is called as full load slip. Is called as full load slip. The full load slip S is equals to ns minus nr by ns. Full load slip S is equals to ns minus nr by ns. ns minus nr by ns is the full load slip. Can you tell me x load slip is equals to x load slip is equals to x into full load slip. X load slip is equals to x into full load slip. X load slip is equals to x into full load slip. X load slip speed is equals to x into full load slip speed. X into full load slip speed. These are the formulas, very important. Right, sir? Actually, we have a formula. Ns is equals to 120 F by P. And is the values from this? F is equals to Ns is equals to 120 F by P. F is equals to P by 120 into Ns. This frequency is called as supply frequency. Supply frequency is equals to P divided by 120 into Ns. P divided by 120 into Ns. These are the some formulas. Right? Now I want the rotor frequency. Right? We know supply frequency. What is rotor frequency? Now I want. What is rotor frequency? The rotor frequency Fr is equals to, see carefully, Fr is equals to P by 120 into Ns difference Nr. This is our rotor frequency. This rotor frequency is for two types, is different for two types. One is for positive sequence, and another one for negative sequence. One for positive sequence, one for negative sequence. Positive sequence nothing but if the stator magnetic field is in this direction, rotor also in the same direction. This is positive sequence. Negative sequence nothing but if stator magnetic field in this direction, the rotor speed is in opposite direction. This is negative sequence. For positive sequence, Fr is equals to, for positive sequence, Fr is equals to, what is formula? P by 120 into Ns minus Nr, because both are same direction. If both are same direction, relative motion is Ns minus Nr. For this negative sequence, Fr is equals to P by 120 into Ns minus of minus Nr. Ns minus of minus Nr. Nothing but Fr is equals to P by 120 into Ns plus Nr. Ns plus Nr. This is rotor frequency for negative sequence. This is rotor frequency for positive sequence. Let's calculate here. Fr is equals to P by 120 into, actually for this, for simplification, multiplied and divided by Ns. For example, multiplied and divided by Ns. 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 What is this value? Can you tell me what is this value? This value is taken as S into Ns. S into Ns can be written as Ns into S. Ns into S. Can you tell me what is this formula? See here once. Okay, Fs is equal to P by 120 into Ns. Fs is equals to P by 120 into Ns. Now comes to here. P by 120 into Ns. P by 120 into Ns is nothing but Fs. So the rotor frequency for positive sequence, Fr is equals to S into Fs, where S is the slip S. Fs is the supply frequency. The rotor frequency is equals to slip times of the supply frequency. This is for positive sequence. What about for negative sequence? Can you tell me what about for negative sequence? Sir, Fr is equals to P by 120 into, what should I do here? Before that, see here once. Generally, we know S is equals to Ns minus Nr by Ns. We saw. S is equals to, slip S is equal to the slip speed by synchronous speed. Ns minus Nr by Ns. Once simplify this one. S into Ns is equals to Ns minus Nr. I want Nr. Nr is equals to Ns minus S into Ns. Then Nr is equals to Ns into 1 minus S. Nr is equals to Ns into 1 minus S. Nr is equals to Ns into 1 minus S. Nr is equals to Ns into 1 minus S. This is my rotor speed. Very important formula. Very important formula. Nr is equals to Ns into 1 minus S. If they given slip value and synchronous speed value, we can directly calculate rotor speed. Right, sir. Now substitute this Nr value here. Nothing but Ns plus, what is Nr? Nr is equals to Ns minus S into Ns. Yes or no? Ns minus S into Ns. So Ns, 2 Ns. So tell me what is formula? Fr is equals to P by 120 into 2 Ns minus S into Ns. 2 Ns minus S into Ns. Tell me what is formula? P by 120 into Ns common. P by 120 into Ns into 2 minus S. P by 120 into Ns into 2 minus S. Can you tell me what is this formula? We saw just now. So finally, what is Fr? Fr is equals to 2 minus S into Fs. Fr is equals to 2 minus S into Fs. The rotor frequency is equals to 2 minus S into Fs for negative sequence, and for positive sequence S into Fs. For positive sequence Fr is equal to S into Fs. For negative sequence Fr is equals to 2 minus S into Fs. 2 minus S into Fs. Nothing but the positive slip is the S. Nothing but positive slip is the S. And negative sequence slip is the 2 minus S. Positive sequence slip is the S. Negative sequence slip is the 2 minus S. For positive sequence rotor frequency S into Fs. For negative sequence rotor frequency 2 minus S into Fs. 2 minus S into Fs. Right? These are the formulae based on speed equations. For speed equations, we have some formulas. One is Ns. Another one relative motions. Nothing but slip speeds. So synchronous speed, slip speed, then after slip, then after rotor speed, then after rotor frequencies. Synchronous speed, slip, rotor speed, and rotor frequencies. These are very important. Right? These are called as speed equations. Right?